You may think HIV exploded onto the world in the 1980s, but by the time doctors finally recognized AIDS, the virus had already been quietly traveling from person to person for generations. Imagine discovering a forest fire only after the flames have crossed an entire continent. That's what happened with HIV. Today, we're going to trace the virus back more than a century, uncover how it crossed into humans, why it stayed invisible for decades, and how ordinary historical changes quietly transformed a single spillover event into one of the largest pandemics in human history. Segment 1. The Silent Beginning. The story does not begin in a hospital. It begins deep inside the rainforests of Central Africa. Long before HIV infected humans, a closely related virus called simian immunodeficiency virus, or SIV, had circulated among chimpanzees for thousands of years. Unlike humans, these chimpanzees had evolved alongside the virus. For them, infection often caused little or no severe disease because host and virus had adapted to one another over evolutionary time. Think of SIV as a long-term resident living peacefully inside an old neighborhood. Problems only began when the resident moved into a completely different city. During hunting and butchering of wild chimpanzees for food, infected blood could enter cuts or open wounds on human skin. Scientists call this a spillover event. Most spillovers probably ended there. The virus entered a human, failed to adapt, and disappeared with that individual. But eventually, one spillover was different. The virus accumulated enough genetic changes to survive inside human immune cells. It learned a new language. Instead of dying out, it continued moving from one person to another. That single evolutionary success changed history. Segment 2. Evolution's Lottery. Many people imagine viruses making deliberate decisions. Biologically, they don't. Viruses copy themselves billions of times, and every copy introduces tiny mistakes called mutations. Most mutations are useless. Many are harmful. A very small number accidentally improve survival. Imagine throwing millions of keys into a lock. Almost every key fails. Eventually, one fits. That is evolution. Researchers comparing HIV genomes from around the world reconstructed a family tree of the virus using molecular clock analysis. By measuring how mutations accumulated over time, they estimated that the common ancestor of HIV-1 group M, the strain responsible for the global pandemic, most likely existed in the early 20th century, around the years 1908 to 1920. Notice something important. Scientists are not identifying the first infected person. They are estimating when today's pandemic lineage shared its last common ancestor. Those are very different questions. Evolution rarely leaves a perfect timestamp. Instead, it leaves genetic fingerprints. Segment 3. The City That Changed Everything. If the virus crossed into humans in a remote forest, why didn't the pandemic begin immediately? Because viruses need more than biology. They need opportunity. Around the early 20th century, Central Africa was changing rapidly. Colonial expansion accelerated urban growth. Railways connected distant communities. River transport linked villages with expanding cities. One city became especially important. Leopoldville, known today as Kinshasa. Think of a single spark landing on dry grass. In the forest, the spark burns out. In a crowded city connected by transportation networks, the same spark can ignite an entire landscape. Cities concentrate people. Transportation moves infected individuals farther than ever before. Social networks become larger. Transmission opportunities multiply. The virus had found something more powerful than mutation. It had found connectivity. Segment 4. Why nobody noticed. Here is the part that surprises most people. HIV did not remain hidden because it was harmless. It remained hidden because of how slowly it worked. After infection, many people experience either mild flu-like symptoms or no noticeable illness at all. Then comes an extraordinarily long silent phase. Years may pass while the virus gradually damages immune cells. Imagine termites quietly eating away at the wooden beams inside a house. From the outside, everything appears perfectly normal. Then one day, the roof collapses. Doctors in the early 20th century had no laboratory tools capable of detecting HIV. Patients eventually developed infections like tuberculosis, pneumonia, or unusual cancers. These illnesses were treated individually. No one realized they shared a common invisible cause. The virus wasn't hiding. Medicine simply lacked the flashlight needed to see it. Segment 5. The invisible expansion. As decades passed, HIV continued spreading quietly across communities. Most infected individuals never knew they carried it. Every new transmission gave the virus another opportunity to diversify genetically. This detail became critically important decades later. Scientists recovered preserved blood samples collected in Kinshasa during 1959 and 1960. When these viral genomes were compared, researchers found something remarkable. The viruses were already genetically very different from each other. That amount of diversity cannot appear overnight. It requires decades of uninterrupted evolution. Think of language. If two distant villages speak noticeably different dialects, they did not separate last year. They have been evolving independently for generations. The same principle applies to viral evolution. By the middle of the 20th century, HIV had already accumulated an extensive evolutionary history inside humans. Segment 6. The perfect conditions. A virus does not conquer the world simply because it is dangerous. It succeeds when biology meets human behavior. Increasing population density, expanding transportation, growing cities, migration, changing sexual networks, medical systems with limited diagnostic capacity. Each factor alone was insufficient. Together, they formed an ecosystem favorable to sustained transmission. Imagine a chain made of many links. No single link carries all the weight, but together they become incredibly strong. Pandemics work the same way. They are rarely caused by one dramatic event. They emerge from many small changes reinforcing one another over time. Segment 7. The discovery that came too late. Everything changed in 1981. Doctors in the United States began seeing clusters of rare infections and unusual cancers among previously healthy young adults. These diseases normally appeared only in people with profoundly weakened immune systems. Something entirely new was happening. Researchers soon realized patients were not suffering from many unrelated illnesses. They were all experiencing the same underlying immune collapse. The syndrome became known as acquired immunodeficiency syndrome. AIDS. Only after years of investigation was the responsible virus identified. By then, HIV had already spread across multiple continents. The pandemic did not suddenly appear. Humanity had simply reached the moment when medicine finally recognized what evolution had been building for decades. Segment 8. Reading history through DNA. One of the greatest scientific achievements of modern biology is that DNA preserves history. Every mutation is like a tiny spelling change copied into the next generation. When scientists compare thousands of viral genomes, they can reconstruct relationships much like historians reconstruct family trees. No eyewitness watched the first successful spillover. No photograph captured the earliest transmission, but the virus itself kept meticulous records. Its genome became an archive. Instead of written documents, researchers read mutations. Instead of historical maps, they built evolutionary trees. The virus unknowingly documented its own journey. Segment 9. Why this story matters today. The real lesson is not that viruses are unstoppable. The lesson is that invisible biological processes often begin long before we recognize them. By the time symptoms appear, important events may already have unfolded beneath the surface. The same principle applies throughout biology. Atherosclerosis develops silently before heart attacks. Type 2 diabetes develops silently before diagnosis. Many cancers grow silently before detection. HIV became one of history's clearest reminders that absence of evidence is not evidence of absence. Our bodies and our pathogens often write their stories long before we learn how to read them. Segment 10. The century we never saw. Looking back, it is tempting to ask why nobody stopped HIV earlier. But that question assumes people could recognize what science had not yet discovered. They couldn't. Instead, this history reveals something more powerful. Science advances by gradually turning invisible mechanisms into visible knowledge. A century ago, HIV was an unknown passenger crossing from one species into another. Today, we understand its evolutionary origins, its genetic history, and the pathways that allowed it to spread. Modern antiretroviral therapy now enables many people living with HIV to live long, healthy lives, while dramatically reducing transmission when treatment is effective. The greatest weapon against future pandemics is not fear. It is earlier detection, stronger surveillance, deeper scientific understanding, and the willingness to investigate the quiet biological changes that most people never notice. The next pandemic may not begin with headlines. Like HIV, it may begin with a single unnoticed event, slowly unfolding beneath the surface until science learns to recognize the pattern. History reminds us that nature is always writing new chapters. Our responsibility is learning to read them before they become global tragedies.